from the homework?
Yes.
The last one, number 68.
Yes. Can you give it to me, or do I need the book? I can open the book.
I had it written down, if that helps.
I can stop being lazy and open my book. Also, 68. And that's, which page are we on there? 100 and something.
Pretty sure it's 115.
Okay, 115, 115. Where are you? 115. 13, 15, and that's 68. Okay, so we have f of x equals negative 2 over x minus 7. Is this continuous on the interval negative 5, 5? And we know from the very beginning that this function is not defined where?
At 7.
Good. So we know that x not equals 7 for sure, but it's not here. So this is the only problem. The only problem. So, and we know that a function, a rational function, is always continuous on its domain. So this is a part of the domain where the function is always continuous. And I can put it and write it that the limit as x approaches a from the left of f of x equals limit of f of x as x approaches a from the right equals f of a for sure for all x in negative 5, 5. Guaranteed. The only value for which this will not happen from the entire real line, not just from negative 5 to 5, will be 7. Can anyone else tell us why 7 and not 3?
Because it's an asymptote.
Very good. Because the denominator is 0. And the denominator being 0 creates the function undefined. Good. Anything else for me?
I did have a question on this one.
Yes, please.
So when I graphed it, I got it because it has an asymptote and it's a rational function. The continuing infinitely in two separate parts of the plane, right? So for that, it was labeled in our notes as infinite discontinuity. That doesn't mean that it's just discontinuous at all points, correct?
That is true. It's only discontinuous at 7. But the discussion here was only on this domain. We were given a piece of the domain. So our discussion happens only between negative 5 and 5. For all x in the interval open, negative 5, 5. But yes, it's a good point. It will have a vertical asymptote at 7.
Okay.
Is that clear?
Yeah, that makes sense. So if it didn't specify the domain, then...
If it didn't specify the domain, I would have said that this is true for all x in the domain except for 7. Is that okay? Okay, for section 1.3, I don't have anything to say. It's the average rate of change. Oops. Difference quotient, that's number 1, and number 2, difference quotient, which we've done a long time ago. We just have to practice and move on. Average rate of change of a function between 2 points, the difference quotient for any function we want to look at, and a measurement unit for both. Is a ratio. For example, dollars per hour. Another example, miles per hour. Another example, degree Fahrenheit per minute. And so on and so forth. 2 measurement units, one coming from the top, one coming from the denominator. One coming from the function and the other one from the independent variable. Okay, on page 123, let's pick problems 1 through 16. They're asking us to find the difference quotient and then complete the table, which we don't need to. I just need to find the difference quotient one more time before we continue. So would anyone like to pick a function, any function you want? Okay, I would pick 16. So this is x squared plus 4x minus 3. Can anyone refresh our memory? What is the difference quotient? What does it equal to?
Professor, are you using the teacher's edition of the textbook or like the regular edition?
I have no idea.
Okay, because on my 123, I don't have a number 16.
No, it's on 122.
Oh, okay, thank you.
If you see 17 on 123, obviously 16 must be on 122. My apologies. Okay, so can anyone give us the difference quotient?
F x plus h minus f of x over h.
Great job. Thank you very much. Good. So this we have. This is not new. Everything was done a long time ago. This we have. The only piece we don't have is this. So can anyone dictate how to determine f of x plus h? Okay, Lake answered already, at least once.
We plug in x plus h wherever there's an x in the original.
Yes, you have to be an expert in this because you gave us a function a long time ago. I don't remember the function, but I named it Haber function. Good. Now, anyone else could anyone else tell us how much is x plus h squared? And not Haber and Lake, or Amanda, because I already heard them, and or Rita, because I already heard Rita.
X squared plus 2xh plus h squared.
Yes, because I tortured him last semester in another class, so of course he knows. Great job. So now this is this. Okay? So the reason why I do this is not for, I'm not a drawing type of person. I'm not capable of drawing nice stuff. Is because I want you to know that this, because I have written other things in here, will continue somewhere. You have to look for this symbol again. So that's the trick. So you know that it doesn't end there. So it will continue here. So that's why this symbol continues here, because I have something written in the meantime. So now I will replace x squared plus 2xh plus h squared plus 4x plus 4h minus 3. Anyone else? How do I continue, please? What do I have to write next?
Take the actual.
Say it again.
You write the actual equation.
So, okay, how do I continue?
So it would be minus x squared plus 4x.
Careful. Minus x squared.
Minus 4x plus 3.
That's it. So minus x squared plus 4x plus 3. What has to happen now? For sure, forever, every time I determine the difference quotient.
The
Terms without
the h.
Very good. The terms without h must go away. Let's see. Do they go away? If they don't, we have to go back and start from scratch. Okay, they did. Can anyone else tell us what is the next step? What happens next?
Would it be to simplify?
Yes.
So it would be 2x plus h plus 4.
We have to factor out h first. We cannot simplify before we show why we're doing what we're doing. So what is left in parentheses?
2x plus h plus 4.
That's it. Only now I simplify this. Trust me, I get lazy sometimes and I don't write it correctly, but it has to be written like this. And this is the difference quotient. Okay, let's look at a word problem in which we are asked to find the average rate of change. Okay, pages 124, 125. Let's choose a word problem in which we're asked to find the average rate of change. Yes, I would like to look at 43. 43 on page 125. So the graph is something like this. We will not be able to read from my graph, but I just want to mimic the graph here. Here it is, something like this. And they asking us to, the red graph represents, it's a function. I don't need the details. Find the average rate of change with respect to time as it changes from 0 to 4. So obviously this point is 0, 0. And I'm reading from the graph, so this point has 4, 500. 4, 500. These points are given to us. This is the function f of x, and we're asked to find the average rate of change. I'm going to call this point A, and I'm going to call this point B. Find the average rate of change between A and B. And this will be f of 4 minus f of 0 divided by 4 minus 0. This is as if I'm only looking at a line passing through these points and I want to find its slope. That's all it means, in short. So if the graph disappears and I just have this line, this will also be the rate of change of the blue graph, of the blue function, and is the slope of AB. And that's what the average rate of change is. So I will have 500 minus 0 over 4 minus 0. 500 minus 0 over 4 minus 0. Of course, I don't need to write that. It's just 500 divided by 4. So this will be 250 divided by 2, 125. It's not enough. I have to write the measurement unit. And I am told population per year. Population per year. So what does this mean again? It means that between 0 and 4 years, every year, the population increased because it's a positive rate of change. You don't have to write the positive. I was just making a point. 125 or 125,000, depending on the measurement unit. So let's look. It says in millions. Okay. So 125 million population per year. And with this, I think we should move on to the next step, 1.4. That's all about this section. We know the measurement unit is a ratio. We know the difference quotient. We've studied it. We spent a lot of time on it. And the average rate of change is the slope of this line, which means how much it increases per year or decreases per year. You could have this kind of slope. It will be decreasing. If it's this, it's increasing. Any questions on this?